All right, question 2 asks you to figure out certain boundary conditions. Now, they say the trig graphs are useful here. If you'd like to use the trig graphs, feel free. I'm going to draw them out for you. Actually, I'll do them both on the one. So if you have sine x, I'll make this 90, 180, 270, and 360, and this is of course 0 because we're going from 0 to 360. Sine always starts at 0, goes up to 1, down to 90, down to this one, like it goes up and down and up. Yeah? No. Sorry, it goes up and down and up. So that's sine theta. If I want to draw cos theta, it's kind of like, that. It's sine theta, but it's been moved across a bit. And these values were 1 and -1. So if you want to know when sine theta equals 1, well, it's when the blue line gets up to 1, so it's at 90 degrees. And if you want to know when cos theta gets to 1, well, it's when the purple line is at +1. So it's at 0 and 360. And if you want to know when cos theta is 0, well, it's here. 90 degrees, and it's also here, 270 degrees. If you want to know when cos theta is -1, it's here, it's at 180 degrees. If you want to know when tan theta, well, I haven't done anything for tan, I haven't helped you yet. And when sine theta is -1, well, it's here, it's at 270. Tan I haven't drawn because I hate it with a passion. Tan, this is 90, 180, 270, 360. Hang on, I always stuff up with tan. Yeah. Oh. So tan theta is 0 at 0, 180, and 360. But I understand that you're going to be hesitant to use these graphs. You haven't got much practice drawing them. You're not going to trust your answers. So let's do it without graphs. So we have sine theta equals 1. So theta is arcsine 1. And that's going to give you 90. Arcsine 1 gives you 90. Now don't forget, sine theta is y on r, isn't it? So it's whenever y equals r. So it's up here. So if, we have a circle, it's only up here, and that's at 90 degrees. For B, we want to know when cos theta equals 1. So if you chuck this in your calculator, it's going to give you 0 degrees. Don't forget cos theta is x on r. So x on r equals 1 when x equals r. So if we draw that, again, we've got a circle radius r, so it's only here. And that's 0 degrees or 360 degrees. So that's only when x is positive r, so it's going positive r across. For C, we've got cos theta equals 0. So theta is arc cos 0, which is 90. But cos theta is x on r, so x on r equals 0 when x equals 0. Now this is the tricky bit. Because x will only be 0 if we're on this circle and we're tracing points around the circle, like here, x is more than 0. Here, x is more than 0. Here, x is exactly 0, and here, x is exactly 0. But here, x isn't 0, not 0, not 0, not 0, not 0. Like it's here and here. So we've got 90 degrees or 270 degrees. For question D, cos theta equals -1. So if you chuck it in your calculator, theta equals arc cos -1, which is 180. So if we did that, cos theta is x on r equals -1 when x is minus r. Draw it. Putting our circle on. So when x is minus r, that's here, yeah? So there is only one spot, that's 180 degrees. Okay, question E, they're saying tan theta equals 0. So theta equals arctan 0, which is 0. So tan theta is y on x. And we're saying it equals 0, but this has to be when y equals 0. It can't be when x is 0, because x is 0 means you're dividing by 0. Can't do it. So y equals 0. Let's draw it. Put your circle on. Y equals 0 here, but also here, because it's like 0 up. So theta is 0 degrees or 180 degrees. Finally, F, they're saying sine theta equals -1. So theta equals arcsine -1. Chuck it in your calculator. Gives us -90, which is 270, yeah? Let's double check. So sine theta, which is y on r, equals -1, only happens when y equals minus r. So if we draw it, so that's when it's -r going downwards, yeah? So theta 270. That's those. You will get better at drawing these, and for all of them except tan, drawing them is the best way to do it. Probably tan too, I've just never been good at that.